the coexistence of FRMCS with GSM-R in terms of the radio spectrum. And for some of you, this will be secondhand, very, very familiar to you. We're just illustrating the current GSM-R spectrum, so-called harmonized spectrum that's available in all European countries. So the base stations operate in the so-called downlink band, which extends from 921 megahertz to 925 megahertz. So it's a bandwidth of 4 megahertz. That's paired with a second block of spectrum used by the mobile devices to transmit in the uplink direction, so 876 to 880 megahertz. So 2 blocks of spectrum, one downlink, one uplink, so it's commonly referred to as frequency division duplex spectrum. But we've only got 4 megahertz, and we currently have just 19 radio channels available to it for GSM-R communications. Now, some European countries, notably Germany and Austria, they've got an extension to the existing GSM-R band, and that extension then gives them more capacity. It provides them with more radio channels. This is referred to as non-harmonized spectrum because it's not available in all European countries, and it certainly is not available here. So we are very, very limited, like many countries, to just simply 4 megahertz in the downlink paired with 4 megahertz in the uplink. Now, considering that the smallest channel size that we have for 5G was originally 5 megahertz, then clearly we can't fit a 5G radio channel into a 4 megahertz bandwidth. It just does not fit. It's okay if you're in Germany, perhaps you can use your extended range spectrum. However, the ECC, the Electronic Communications Commission, have come to the rescue with their decision 2002. They provided an additional 1.6 megahertz, which we can add onto the bottom of our existing GSM 900 spectrum. So that will take us down to a frequency of 919.4 megahertz for the downlink, and the uplink will be extended down to 874 decibel 4 megahertz. So we've now got a total of 4 plus 1.6. We've got 5.6 megahertz. So potentially, we can fit a 5G 5 megahertz radio channel into our radio spectrum. This extended band shown in green that's been made available for the railways is now referred to in the 3GPP specifications as N100. So it's band N100. The letter N stands for new radio, and that is the terminology associated with the 5G radio technology. But what has also been made available to the railways in ECC Decision 2002, an additional 10 megahertz at 1900 megahertz has been made available. And this is referred to as band N101. It extends between 1900 and 1910, and it's not paired with anything. So the only way we can use this spectrum is by using time division duplexing. So we've never done this before. This is quite new for the railway world. So how can we make the best use of this spectrum? Okay, if we take the downlink spectrum or the uplink spectrum, it makes no difference. We've got 5.6 megahertz of spectrum to play with. And I said previously that the 5G new radio channel is 5 megahertz wide. So try to fit your 5 megahertz into the existing 5.6 megahertz. And you can see there's a little bit of space left over. And we could potentially have 2 or maybe 3 GSM-R radio channels. Now, clearly, if we want FRMCS and GSM-R to coexist, GSM-R is going to come off worse here because there's just not enough capacity. 2 or 3 GSM-R radio channels is just not enough to be able to actually sustain our existing GSM-R communications and applications. Actually, things aren't quite so bad. This 5 megahertz they talk about is referred to as the channel bandwidth. What is actually transmitted is actually slightly narrower. The transmitted bandwidth is actually 4.5 megahertz wide. The reason being there is a guard band at the top and there is a guard band at the bottom. And that's because what we're going to do is transmit what are known as 25 resource blocks. A resource block is the smallest amount of radio resource which the base station can schedule for a mobile device, either to be used in the uplink or in the downlink direction. One resource block has a bandwidth of 180 kilohertz, and that's assuming we have a sub-carrier spacing of 15 kilohertz. If that doesn't mean a great deal to you because you never perhaps work on 4G or 5G, don't worry too much about it for the moment. So basically, we've got 25 resource blocks. Each is 180 kilohertz wide, so when you multiply the two together, your transmitted bandwidth is 4.5 megahertz. So potentially, if we were to maybe just move this down slightly, bearing in mind we do need a guard band to ensure that we don't interfere with neighboring services, but if we could move that down a little bit, that might just give us an extra 1 or 2 channels. But I think really, to be honest with you, 3 or 4 channels for GSM-R living alongside FRMCS is still not really that practical.